Hello everyone, my name is Brandon Lewis, and today we're going to be discussing tsunamis. Now this is a really cool topic, I think it's very interesting, and I plan on keeping your attention by giving you some really good pictures, illustrations, and videos, and some great knowledge. Now, I want to first discuss with you this beautiful symbol that I came across, which is the tsunami symbol in Japanese. And what it pretty much translates into is harbor wave, which I thought was interesting. Now, I'm going to show you here a globe. Some of the most destructive tsunamis hit the coast of the Pacific and the Indian Ocean. However, it's important that you know that the coast of the Atlantic Ocean and the Mediterranean Sea still have tsunamis as well. However, they have fewer tsunamis. Now, this is a globe. I'm sorry, this is the Earth here, and I wanted to peel it back and show you the different layers. Now, keep in mind that inner layer gets 9,000 degrees. Now let's go ahead and give you a 3D view of this. Now that radioactivity in that center core keeps that heat hot, which I said it goes up to 9,000 degrees. And what it does is it starts to penetrate those other layers, and that heat just constantly bursts out, and all that heat just recycles. It goes up to the surface, and it comes back down to reheat, and it comes back up, and it goes down to reheat. It's pretty much like a boiling pot of water, and it never stops boiling. And like I said, that radioactivity is constantly circling throughout the earth. And what it causes is for these plates to start shifting. And as you can see, those plates are shifting, is starting to form those continents. And those are all the different fault lines where you have all those different collision of the sheets there, of those plates. Now this is a video of an earthquake which is caused by those collisions of those sheets. And what happens is when that earthquake occurs, you get the collision of the sheets, which causes the fault line here. And this is going to create that upper wave, which is this is the tsunami genesis diagram, and it's going to show you how that upper wave is formed to create a tsunami. Now here I have a photo of an underwater fault line underneath the sea, on the ocean floor. Now this is a diagram to show you that earthquake. Now once that earthquake happens, as you can see, there's a vertical displacement of water, and there's a simulated boat, and as you can see, there's a column underneath that boat. And also the wave can travel thousands of kilometers from its original location in other countries, believe it or not. Now the wave isn't noticeable if you're on the sea. They usually are only 1 meter high waves if you're on the sea. So you may have driven over it and not even notice you was in a tsunami. Now this is the column I was telling you about with the simulated boat. Now the tsunamis can travel up to 800 kilometers per hour. And I wanted to show you here the sudden movement of that earthquake causes that entire column of water particles to move, versus a regular wave, which caused by the wind. It only affects the top 3 or 4 layers of water, which creates those circular motions in that water particles. So as you can see, not the entire column like a tsunami is affected, which is not going to create a larger wave like a tsunami. You only have like the top 3 or 4 layers that are affected. And what it does is the waves, when those wind waves hit the beach, it's only the first couple meters that affects how hard the wave hits. And as the wave gets closer for a tsunami, the entire sea column elevates off the floor, and it starts to slow down the tsunami wave. However, the energy of the wave and the height remains the same. That's something that you need to know. Prior to the crest of the wave hitting the beach, as you would notice, the water would start to recede. Now this is the first warning sign. The water starts receding from the beach, and also if you was to visit your harbor, you will also notice that the water is receded there as well. And this is when you want to go ahead and evacuate and seek higher grounds, because the first wave is soon to follow. And it looks like a high tide coming in, but it really isn't, and it's not going to be pretty. It is a tsunami. Now, when you're detecting a tsunami,
and Indian Oceans
that's what you want to do. Now,
tsunami is generated.
they have this cool
These systems rely on
technology
sensors
planted on the
placed at the
floor
sea bottom, which measure
on the Indian
variations
Ocean
in the water
and
above
also the Pacific
and transmit
Ocean. And it
an
measures
alarm via
the waves
floating
in
buoys
the ocean
and
by
satellite
floating
linkups
buoys,
with
and
observation stations on the
links
coast.
it up to the satellite. Now this is March 11, 2001 in Japan. So now check it out. Watch how far the tsunami wave travels inland in just 2 minutes. Tsunami quickly makes its way up. Without any resting, it continues to surge forward. This is that great energy that comes from the earthquake itself, not from the wind. And it doesn't stop, it doesn't let down. It just continues to flow, continues to go. Because the tsunami wave energy is constant speed, once it gets on shore, the damage caused to the shoreline is absolutely extensive. And a tsunami doesn't need long to make a devastating impact. Take a look at this video and show you how far it goes inland. Without any rest, tear away the shoreline, ripping apart all types of structures, from homes, businesses, office buildings. 19,000 lives were lost. Absolutely amazing. Nothing is safe. $574 billion in damage. Damage is going as far as 10 kilometers inland. We must pay our respect to those people who lost their lives. And all to people in Japan. Watching my video. Brandon Lewis, I hope you enjoyed it.